Hello all. Welcome to the part 2 of K-means clustering algorithm. So in the previous session we have seen how what K-means clustering is and how we can actually cluster or classify your various data points into multiple clusters. So whatever cluster number is given, so those many clusters are formed. So let's take one more exercise that is kind of working with some data set which can be where we can apply k-means clustering. Let me use Excel file. I have one. So let me find out if I have here volume, map data, and data, and I have one cluster. Yeah, cluster problem data sets. Let me just find out. I'll use this. Let's say I use it as a data here, and data dot head. Okay, you can find that there's a carbon dioxide emission and GDP per capita in US dollar and the country name. So this is a simple kind of a data set where we want to try and apply k-means clustering to cluster various countries into various groups based on the data, right? So definitely there's no label, there's no feature given, we don't have to do anything with respect to features, but we can try and explore the data first, and let's try and see what data it is, right? So carbon dioxide emission, that is 232 data points. The GDP per capita is 228. That means there are 4 missing. So that missing data we have to see what we can do with. And there are few records where the missing is there, and the country name, there are 232. That means there is no country missing as well. So the very first thing for before any algorithm, as we have been discussing this while we learned about supervised and unsupervised supervised machine learning algorithms in regression and classification, we have to deal with the missing data. The algorithm won't work if there is any missing information, because it will not it should not be biased with respect to any particular variable. We have to make sure that the data is present for all the variables if we are using those variables for any algorithm in machine learning, right? So very first thing, I would like to drop them since there are only 4 records. It doesn't make sense to add some per capita income, per capita GDP. That is not going to help. Instead, we can drop as the number is very less, right? So usually, if it is a little bigger number, we can think about updating it. Again, it depends on case to case basis. But here at least in this example, we can drop those 4 records using a drop NA function. Okay, so drop NA can be used here, and directly it will drop your records. You can use it true, and now data dot info will give you 228 for each of the records. Okay, so this is how your drop function works. And now let's get your all the data points. I will get it x using ilog function, and here I want to get all the rows, so I don't specify anything, any filter here in the slicing syntax, but I want to get the 2. Okay, first let me see where these 2 are. Data dot head. Okay, I can see that I want to get the country name as as the country of our interest, where we want to categorize based on these features. So this is a basic thing, but yes, now we are actually doing this. But if you are not sure, you can skip this and use the values whatever you find. So for now, let's get x dot head, and I will see. Okay, sorry, this is a numpy, so I'll just check some values here, maybe first 10. Okay, you have some values. So okay, those are the values which you get from the data set. Now let's do a feature scaling. The reason is these numbers, if you see, there varies. Like this is like a 1 digit or 2 digit number, but this is like in thousands or 10,000s or hundred thousands in that particular range. So that is being said that these are bigger numbers, so that does not mean this has higher weightage over this. The variables are important, so every variable has a different weightage, but it is not depending on the numbers. So hence we want to normalize the data which is there in the data set. So for these variables like GDP per capita and carbon dioxide emission, so we use a feature scaling class, feature scaling. If you recall, we have used this earlier as well. So s equal to standard scalar. Okay, I need to import from sklearn dot pre-processing, I think. Okay, inside this you'll find import standard scalar. Perfect. So you can create a class for this. This is how you can create. Now you can change the you can actually feed the data. So fit transform you can use to give your x data points here, and once you give this x data points, now we don't have to divide this data into training testing, but because this is more of a the whole data we want to put together for clustering, right? So transform with on the x. Let me try and see how x looks like. Yeah, x is now converted to some numbers between some range, maybe -10 to +10 or some range, whatever the algorithm it applies. So basically it normalizes all the values. Okay, let me print 22 and move on. So this is how we see your x here. Now x, I would like to convert it to a data frame back, because I want to see okay, let me try it. If it works, I'll explain. Columns equal to let's say carbon dioxide 2 and okay, carbon dioxide and GDP. Okay, let me see. Okay, so this is the same thing we have actually done, right? So we have converted back to our data frame. So so we want to use these values along with probably, let me try and see how our data looks like. Okay, here is the data. Okay, let me do one thing. Okay, I can directly use this, but somehow I think we can add these two values. Okay, maybe let me try and see if it works. Concatenate your data and your x. Okay, that is the x you got. X is equal to 1, and I don't want to work with the indexes. Okay, country, GDP, carbon dioxide emission, and here additional 2. Okay, anyway, this index is ignored, I think. Ignore index, let me see. Ignore index is false. I want to make it true. Yeah, so that on the indexes we have just removed them. Okay. Okay, fine. I think let me take this as a data now, so that we can see and fetch some of the columns back again. I'm doing this exercise to demonstrate one point. Let me first achieve. Once I am done with this, I will again explain. So 3, 4. Okay, this is what. Let me check once again. Data. 0, 1, 2, 3. Okay, 3, 4. Oops. Okay, this got added twice, so that's not bad because I learned this twice. So hence, let me run once again. Okay, concatenation we should do only once, right? And then only it is like 3 and 4 because I want last two columns back. Um, yeah, so df. Okay, let me see. Actually, we got to the same data frame again. Um, because I thought I used X, but the data is in categorical, right? Okay, let me apply the algorithm that is something called elbow algorithm, elbow method on how we can work with this data set. For now, we will work with this data frame, right? So data frame df is nothing but your same data set, okay, the original data set where you have carbon dioxide emission and the GDP per capita. So we have this df exactly the same thing, okay. We have just converted it back and then created a data frame again. So this exercise we can ignore for now, okay. Just focus on the df, which is actually having the numpy data without the headers, and we have the same data which is actually the feature scaled, okay. Now let's try and apply the k-means algorithm, and basically we will use the elbow method to know how many clusters, cluster values, right? To know the cluster value. Okay, so that's what the k value means, right? It's a k value. Okay, we can do one thing here for I in a range of, let's say, 10. Okay, or maybe I'll go with 1 to 10, 1 to 10, including both. We will find out k-means manually for each of the data with n number of clusters like 1, 2, 3 and 4 and so on, and then we can probably try to see who is doing better, and then we can actually derive which cluster number is better, right? So let me check a couple of other options with k-means. What is this? Maxitor, then the random state. Okay, I think we can just use the random state to be sure that this random state 0 every time, because on every iteration it works on the same data, right? And that's why. So random state is the only important thing it seems. So I apply this, train this model for our data frame, and then I want to print the k-means inertia. Okay, let me see if it works. Inertia. Okay, this gives you a graph. Maybe I'll use append and add this k-means inertia. Okay, I will have to use LST, empty LST, and once I'm done, LST, I want to print. Let me see if something happens here. Okay, sorry, LST. Okay, we are getting some values. I don't want to print for now, so let it work. Yeah, this inertia, we got this for all the 10 different runs, okay, for the k-means. So let's figure out how we can actually plot this with the help of all these 10 different iterations. So we are running 10 times the k-means algorithm on your data and trying to find out how it looks like. Okay, maybe I'll do one thing. I'll plot and that way it will help you. So let's say plot and a range for 10, 0 to 11, and then I will give a list of all the inertia we have calculated. Probably, let me see, yes, it does this. So I want to, okay, this is the elbow method because this is where the the sudden drop for the values when you calculate inertia for different values. So let's say I equal to 1, 2, 3 and so on. So let's try and see c equal to let's say, okay, I'll use one red color for this, and I'll use a marker equal to, let's say, O. Okay, and I want to use a edge color as well. It is up to you. If you want, you can use edge color equal to blue. Okay, something went wrong with one of the variable. Okay, there's no property called edge color for plot. No problem. So I'll remove that. Yeah, this is also good for us. Okay, so this gives us the key value where you find more appropriate value for finding the k-means, so k value from your data set, right? So the k-means clustering can be done, that means it is better for the value which is where you find that elbow, the sudden drop and then slowly gradual drop. So that means the point either 3 or a 4. So 3 is the more relevant, it looks like. So from here it was a sharp drop, and here it is slowly a little down here. So we can see key value as 3, and we can now try and apply our k-means algorithm on our data with k as 3. So that will probably give you a better clusters that you can try and use to predict. Okay, so maybe I'll do this vibrate equal to km dot fit predict. I think, let me try with the data set. Okay, I think it worked. Let me try and print vibrate. Okay, I think this has given us the clusters with the numbers like 0, 1, 2. Okay, these are the 3 clusters it forms. Maybe I can try and find out the group. So that means the cluster centers. So that gives us the idea how we can plot. In fact, so maybe I'll use g equal to data we have. This is the original data we have, and I want to group it using the name cluster, let's say. And now cluster 0 is g dot get group. Let me see if it works. If it is not working, let me see why. Cluster, oh yeah, group by. Okay, I think I can do one more thing here. So I do add this cluster equal to vibrate. So now you got your vibrate. So you should see that predictions as well here. So this entry belongs to a first cluster 0, and this belongs to the second cluster, and so on and so forth, right? So hence we can actually use and group by them, and we can find out the various groups here. 1, 2. Okay, so maybe we got these 2 groups. Then km dot center cluster centers. Okay, this is how you get the cluster centers. So I have one the one more piece of code which will do plot. I have copied this from my earlier notebooks. Okay, so I'll just put it here, and I will explain you how we are actually displaying those data points which are formed as a cluster here, right? So you can see that how we have these 3 different centroids. That means 3 different clusters formed: the red colors, blue colors, and the green color clusters. So this is how the clustering can happen. So here you can see these are the 3 clusters, and we got the centroids. So these centroids are already plotted here. So this is just a visualization, but otherwise your work is actually done here, right? Here you identified how many clusters you have, and how it looks like. Okay, so this is the simple exercise which actually gives you the glimpse idea about how exactly to use in some of the scenarios. So you may have to do some more feature engineering if you have more data. So this is a simple example. So we had only two variables to consider here, but in reality if you have more data you may have to explore more and do some kind of a feature engineering before you actually apply. So remember that elbow method is used to identify your k value, whether it should be k equal to 1 or 2 or 3 or 4. So there is nothing no other process, but elbow method will help you to get either 3 or 4. There is again there is no fine tuned formula which will exactly tell you what value you should take, but it is based on your visualization or your gut feeling or maybe your analysis of your data. You may decide on your number of clusters. Okay, mostly the analysis of your data, right? That's important. If you know data, if you understand how many clusters you want to form, there's a elbow method will help you to to make that decision a good decision for yourself, right? That gives you a little more confidence to make such decision to decide on how many clusters you are looking for. Okay, so that is what the elbow method is used for. And otherwise, the once you are clear about how many clusters you are looking for, it is matter of just running the k-means algorithm, the model which you can use the class. You can create the object and start training your model for the existing data. So this is how you can you get this number of clusters for your data based on this approach. Okay, so this is all about the k-means clustering, where we have tried to explore and learned about how we can implement some model using k-means clustering. I hope you understand the entire notebook. Please go through that once again, and then you will understand how we can make it. Okay, so okay, thanks for watching. See you in the next video.